Hi to all. In the last class, we discussed about position time graphs. Now, I am going to explain velocity time graphs. Okay? Our topic is velocity time graph. Now, let us see. First, I am going to draw the velocity time graph for a body which is at rest. Okay? Which is at rest. First, rest body. For the rest body, I am going to draw the velocity time graph. Now, in this case, the rest means body is at rest. Rest means its velocity is what? Its position is does not changes. That is, change in position is 0. No change in position. That means now the velocity of the rest body is also equal to 0. It is time independent, right? Now the graph we will get like this. This is x-axis and this is y-axis. Okay, this is x-axis and this is y-axis. And now let us see. On x-axis I am taking the time, and on y-axis I am taking the velocity, because it is a velocity time graph. Tell me, at time t equal to 0 second, velocity is 0, 0 comma 0. After 1 second, for example, this is 1 second, and this is 2 seconds, and this is 3 seconds, and this is 4 seconds, right? After 1 second, its velocity 0, 1 comma 0, 2 comma 0. After 2 seconds, it is 0, x 2, y 0. That means now 3 comma 0, 4 comma 0, we will get a straight line like this. Okay. Now like this we will get the velocity time graph. It is along the x-axis. Along the x-axis we got the line, means y is 0. All the points we are getting on the x-axis. All the points are on x-axis means y will be 0. What is y? Velocity is 0, right? And for the rest body, the body which has 0 velocity, right? For this the graph will be like this there. And the second graph I am going to draw for the uniform velocity, right? Uniform velocity. Uniform velocity means what? Right? Uniform velocity. What is uniform velocity? Velocity, if it is constant, if the velocity is constant, then we say that is uniform velocity, right? When velocity is constant, what is the acceleration? What is the acceleration? Right? Acceleration, what happens? Then acceleration is change in velocity by time. Is it right? Change in velocity, final velocity minus initial velocity by time. When velocity is constant, change in velocity is 0, final velocity equal to initial velocity, then acceleration is 0. When a body moves with uniform velocity, it does not have any acceleration. And now let us see how the graph will be there. Now let us see. For example, I will take one car is moving on the road. Okay, one example I will take. Okay, one car is moving on the road. Let us see. This is the car. This is a car. It is moving like this. Okay, at starting 0 seconds, the velocity is considered as 5 meter per second. Okay, now after some time it will goes to somewhere here, right? And here also its velocity is after 2 seconds, right? Its velocity is again 5 meter per second. Now after 4 seconds we find out its velocity. Let us consider, this is an example. Okay, after 4 seconds, right? And here it has a velocity 5 meter per second. Now that means its velocity is not changing with the time. Its velocity is not changing with the time. The time is increasing but the velocity is the same. Now for this, how the graph will be there? Let us see. Let us take the values for this. The time is on x-axis and velocity is on y-axis. Let us see the graph. Before drawing the graph, we require some values. And here, starting 0 seconds. At 0 second velocity is what? 5 meter per second, right? 0 comma 5. And after 2 seconds, what is the velocity? Again 5 meter per second. After 4 seconds, what is the velocity? Right? Again 5 meter per second. After 6 seconds, what is the velocity? Right, again 5 meter per second, means velocity is not changing with the time. Now let us see the graph. How you will get the graph? Now let us see. The time is taken on x-axis. Okay, the time is taken on x-axis and the velocity is taken on y-axis. Then how we will get the graph? Let us see. This is 0 second time and this is considered as 2, 4 and the 6, 8. This is the time interval. Okay, this is the velocity we will take. Velocity at here is 5 meter per second and at here is 10 meter per second. Okay, and let us see how the graph we will get. And before drawing the graph, we require point. First time 0, velocity 5, 0 comma 5. Time 0 means x0. On x-axis we are taking the time x0 and on y-axis 5 meter per 0 comma 5. This point is like here. Okay, and next 2 comma 5, right? x2, time is 2. The time is 2, this one, right? And velocity is 5. Time is 2. Velocity is 5. Here it will be there, right? And at 4 second, this the time is 4, but the velocity is 5 meter per second. Time is 6, velocity is 5 meter per second, right? Time is 8 second, velocity is like this. Now we got a straight line when you join all these points. What you got here? We got a straight line, right? This is a straight line and this straight line indicates that uniform velocity. Here the velocity is constant. Velocity is constant. When the velocity is constant, then what is its acceleration? Right? Can you tell? Yes. When velocity is constant, the change in velocity is 0. When change in velocity is 0, then acceleration is also 0, because acceleration is the change in velocity per unit time. If there is no change in velocity, no acceleration, because acceleration is change in velocity by time. Change in velocity by time. When there is no change in velocity, no acceleration, right? Okay. Now this is velocity time graph for what? For a body which is in uniform motion, or it is moving with uniform velocity. And let us see the third graph I am going to draw. The third graph is for uniform acceleration. Uniform acceleration. What is the meaning of acceleration? What is the meaning of acceleration? Acceleration means accelerating. Here I am taking acceleration, uniform acceleration means acceleration is constant. Acceleration is constant. Okay, acceleration formula is what? V minus u by t, change in velocity by time. This acceleration should be constant. Okay, acceleration is uniform. Acceleration uniform. Uniform means constant. Acceleration should be constant. Now when we will get the acceleration constant? For example, if v minus u constant, okay, change in velocity constant and time constant, okay, v minus u and t constant, then if v minus u and t constant, then acceleration is also constant, right? Then acceleration is also constant. That means what is the uniform acceleration definition? Okay, if a body has equal change in velocities, this v minus u should be constant, means equal change in velocity in equal intervals of time. If a body has equal change in velocity, if a body has equal change in velocity should be constant. Okay, in equal intervals of time, in equal intervals of time, then that body has uniform acceleration. Okay, then that body has uniform acceleration. This is the condition for uniform acceleration. What is the condition? Equal change in velocity and equal time. Look at here. This is the equal change in velocity and equal time. Means change in velocity equal, time equal. This is constant, this is constant. Then acceleration is automatically constant. Right? And now let us see how the graph will be there for the uniform acceleration. Velocity time graph for uniform acceleration. Okay? Now listen very carefully and take a screenshot and note in your fair notes. Okay? Can I rub it? Now. Okay. Listen very carefully and now let us see, and we are going to draw the graph for a body which is in uniform acceleration, which is moving with uniform acceleration. Let us see how the graph will be there, and for that listen very carefully. And now one example I will tell. Okay, in that this is a car. Okay, it is moving with some speed, right? And now the starting, if time is equal to 0 second, right, and the velocity is considered as 5 meter per second. After 2 seconds, it is at somewhere at here. Now, after 2 seconds, its velocity is 10 meter per second. Okay. Next, after 4 seconds, its velocity is 15 meter per second. Okay. Like this, the object is moving. Now the car is moving right side. What happening at here? What is the time interval between these two? Time gap 0 to 2 seconds. In that, what is the change in velocity? 10 minus 5 meter per second. And here, what is the time gap? 2 to 4. Matlab time gap is 2 seconds. And here, what is the change in velocity? 15 minus 10, 5. Here change in velocity 10 minus 5, 5. Here change in velocity 15 minus 10, right? 5 means here 5 meter per second change in velocity, here also 5 meter per second. Okay, here the time interval 2 seconds, here also time interval 2 seconds, means equal change in velocity is 5 meter per second, 5 meter per second, and equal intervals of time, this interval 2 seconds, this interval 2 seconds. If any object goes like this, right, the rate of increase is the same. In first 2 seconds, how much velocity increased? 5 meter per second. In the next 2 seconds, 2 to 4 gap, how much velocity increased? 10 to 15. Means the increase in velocity for certain time is constant, right? The change in increase in velocity, only change in velocity, right? That is uniform acceleration. Okay, uniform acceleration. Now let us see. In this uniform acceleration, if we take the values to draw the graph, right? This is the time and this is the velocity. Time and velocity. And let us see, first 0 seconds, the velocity of object is 5 meter per second. And next, after 2 seconds, its velocity is 10 meter per second. After 3 seconds, its velocity is, after 4 seconds, its velocity is 15 meter per second. Can you tell after 6 seconds, what is its velocity? Can you tell? Right? For every 2 seconds, how much velocity increasing? 5, right? Now time is increased by 2. Time is increased by 2. Velocity is increased by 5. That means next one is what? 20 meter per second. Very good. And now let us see. Let us draw the graph by taking the values. Okay. Now what we have to do at here? The time we have to take on x-axis and the velocity we have to take on y-axis. Let us draw the graph. Okay. Chalo. Now time we will take as 0, 2 seconds, 4 seconds, 6 seconds, 8 seconds. S is a second. And the velocity we will take as 5 meter per second, 10 meter per second. Okay, tell me. Next, 15 meter per second, 20 meter per second. Right? Actually, we should have to draw by taking a graph. Okay. And now what you will get the graph? First 0 comma 5, right? Time 0, velocity 5. This is the case. Next 2 comma 10. 2 is this one, 10 is this one, right? We will get like this. 2 comma 10, x2 y10, x2 y10. This is the point where they will intercept. And next 4 15, right? Look at here, we will get like this. This is the 4, right? This is the 15. Okay, like this we will get. And if you want the 6 at 6 second, what is the velocity? Yes. Now let us see. Let us join these all things. This is the graph, right? How you will get the graph? This one simply will draw like this. This is time and this is velocity. Now how you got the graph? The graph we will get like this, right? This is the graph, and the graph we got like this. This is the graph, right? We got like this. Here the starting velocity is u. Here the 5 meter per second is the starting velocity. After some time t, okay, after time t, the final velocity, this is the final point. This is the final point, okay, 20 meter per second. That this is the final velocity. Like this, the graph will be there. Okay. Now let us see. By using this graph, we can find out something. What is the significance of this graph? Here the velocity is increasing. Velocity is increasing. Here the body starts with initial velocity 5 meter per second. In this case, u is not equal to 0, right? Okay. If body starts with uniform, body starts from rest and moves with uniform acceleration. Moves with uniform acceleration. Then what happens? Okay, let us draw the graph for that case. What happening it here? Okay, in this case, whether the acceleration is positive or negative in this case. Okay, for this graph, here for this graph, acceleration is positive. Why? The velocity is increasing. Final velocity more than initial velocity. Acceleration is positive. If body starts from rest and moves with uniform acceleration, right? Then the graph, velocity time graph, you will get like this. This is the time, and the velocity is taken on y-axis. Then how you will get the graph? Here starts from with initial velocity, non-zero initial velocity, right? Here u is not equal to 0. Here u is 0. We will get the graph like this. u0 means when time 0, u0 starts from rest, right? Here the body starts with the non-zero velocity, but here we are taking that if body starts from the rest, then initial velocity we will take as 0. Initial velocity 0 means initial time is 0, velocity 0 means it starts from 0 comma 0, right? 0 comma 0 means it starts from origin. Okay, this is the velocity time graph for uniform acceleration. Now here we got the velocity time graph as a straight line, okay, and for the uniform acceleration, here velocity is increasing with the time. Now in this case, whether the acceleration is positive or negative, tell me. Acceleration is positive or negative? By in that example, acceleration is positive. Why the acceleration is positive? Because final velocity is more than initial velocity. Look at here, final velocity more than initial velocity. That's why. Okay, what is the significance of this velocity time graphs? Okay, and before that, let us see. Next, first we went for the rest. Next, uniform velocity. Next, uniform acceleration. Next, uniform retardation graph we will draw. Okay, first rest completed, uniform velocity completed. Okay, next uniform acceleration completed. Next let us see, next point is that uniform retardation. Uniform retardation. Okay, let us see uniform retardation. Uniform retardation. How the graph will be there? What is retardation? Oh, sorry, before this I will tell about this graph something. What is this graph? Here we got the velocity time graph is like this. Okay, this is the velocity time graph. Okay, velocity time graph, what you got? Like this we got. What this indicates? Okay, this indicates that it has positive acceleration. Let us see. First we will draw the significance of the velocity time graph also. Okay, significance of VT graph. What is the use of the VT graph? Okay, let us see. The first important point is that the slope of velocity time graph, slope of VT graph indicates, slope of VT graph indicates acceleration. Acceleration, this is the first point. Okay, acceleration is equal to, okay, first we can find out the slope, whether it will show the acceleration or not. Let us see the slope of VT graph. Slope of VT graph. How to find out the slope? You know na already? Right, you know. The slope, to find out the slope, okay, we have to take the 2 points in the graph, right? 2 points we have to take. This is the one point I will take, and another point I will take it here. Okay, this is another point. This point is A and this point is B. Let us see, we have drawn the vertical line set here. This will indicate T1, this will indicate T2, and now corresponding values of velocities. At T1 time the velocity is V1, at T2 time the velocity is V2, right? And this is the velocity time graph. Okay, look at here, and this velocity is V2. Look at here, we are taking the 2 points on the graph. A time T1, at time T1 velocity is V1, and another point B at time T2, B corresponding time T2 and velocity is V2. And let us draw one triangle at here. From this, if you will get one triangle. And what is this? What is this? Okay, this triangle we will take as C, ABC. Okay. Slope, this angle we will take as theta, this angle we will take as theta. Okay, remember it. This angle is theta. This angle is theta. What is slope? Slope formula is one formula tan theta, right? What is the formula for the tan theta? There is a triangle. There is a triangle. And this is theta. And this is, for example, delta y. Okay. Delta y means difference in y coordinate. Delta x, this one. Okay, this is y2 minus y1. And delta x means x2 minus x1, difference in x coordinate. Then we know tan theta is equal to, what you know tan theta is equal to? Difference in opposite side by adjacent side, right? Opposite side is what? Delta y, theta opposite side delta y, adjacent side delta x. Then we will get y2 minus y1 by x2 minus x1. This is the formula, right? And slope, one formula is tan theta. Theta is angle made by the graph with x-axis, right? Theta is angle made by graph with x-axis, right? With x-axis, positive x-axis. Now, slope of VT graph, what you are getting? Tan theta. Okay, tan theta is what? Tan theta is what? Tan theta equal to opposite side by adjacent side. What is the opposite side at here? BC. right? Adjacent side, theta opposite side, this is a triangle ABC, okay, ABC, tan theta equal to BC by AC, right? BC by AC, BC by AC. What is the BC? BC value how you will get? And here you see this is V2, okay, and this is V1. How like that? How you will get like this? Okay, this is V1 point means this distance is V1 from origin. This is V2 point means this point distance from origin is V2. This is V1 and this is V2. And what about the BC? BC is V2 minus V1, right? That is V2 minus V1, right? This is V2 minus V1. And now BC is V2 minus V1. What is AC? AC is T2 minus T1. AC is this one. AC, this part distance we want. From this, when we subtract this from this, then we will get that part V2 minus V1 by T2 minus V1. Or otherwise, slope formula in 9th class you will learn, that is in the mathematics, difference in y coordinate V2 minus V1 by difference in x coordinate T2 minus T1. Y2 minus Y1 is the difference in y coordinate. Y coordinate are V1, V2, V2 minus V1. X coordinate is T2 minus T1. This is change in velocity by time, right? Change in velocity by time, what it will indicates? It indicates acceleration. Very simple, right? That means now if you find out the slope, right? If you find out the slope, it will shows the acceleration. That is acceleration is equal to tan theta, okay, tan theta, or we write slope of VT graph. Slope of VT graph. What slope of VT graph indicates? Acceleration, right? Acceleration is the slope of VT graph. That is acceleration is equal to tan theta is equal to V2 minus V1 by T2 minus T1, right? And now when we will get the acceleration positive? If theta is positive, right, then acceleration is positive because acceleration is equal to tan theta. If theta is negative, then acceleration is negative, okay? Acceleration is negative. And theta is what? How we will take the theta? Theta is, for example, this is the positive x-axis, right? This is the x-axis. If the graph is like this there, okay, this angle with positive x-axis, this we will take as positive, okay? This we will take as positive. Anti-clockwise angle, like this it is there with positive x-axis. If you will take the angle like this, this is anti-clockwise angle. Anti-clockwise angle we will take as positive. In the last class also we discussed the same thing. And now if the graph is like this there, okay, if the graph is like this there, right, look at here, this is x-axis, like this the graph is there, okay, this is y-axis and this is x-axis and this is y-axis. You take this as x-axis and here you take the angle, this angle is below x-axis, this we will take as negative. Above x-axis angle is positive and below x-axis angle is negative. If you take this one like this also negative, this is, for example, this is like this there, this is x-axis and this one is the graph, okay, and here angle is theta like this there below x-axis, this we will take as negative. Look at here, below x-axis means clockwise angle we will take as negative and anti-clockwise angle positive. When theta is positive, right, then acceleration is positive. Acceleration positive means when a body has positive acceleration, velocity increases with the time. And let us see one more. The first point is that the slope indicates the acceleration. Okay, slope of velocity time graph indicates the acceleration. And now second point also there from the velocity time graph. One more thing we will find out, that is second point is that area under velocity time graph indicates the displacement. Area under VT graph, area under velocity time graph, area under velocity time graph with x-axis, right, gives displacement, remember it. Okay, if you find out the area, it will give displacement. Okay, if you find out the slope, it will give the acceleration, and if you find out the area, it will give the displacement. Matlab, that means displacement is equal to what you will get, area under velocity time graph, area under VT graph. Okay, if you find out the area under VT graph, then we will get the displacement. How you will get like this? For example, this is the VT graph. VT graph is a straight line. Okay, uniform velocity. For example, you can this is the time t, this is the time t. Okay, this velocity is v, for example. Okay, this is the time, and this is the velocity time graph, this one. And now in this velocity time graph, okay, we got a straight line for the uniform motion body. And here this area you can find out, this area. How to find out the area, do you know? Yes, can you find out? Area is equal to length into breadth, right? This is the length and this is breadth. What is the length at here? Length is t, right? Breadth is b, t into length is t, breadth is velocity. This is here v means this distance is v, here t means this distance is t, right? Here we have the time length into breadth formula. That is, length is time, because on x-axis we are taking the time, and breadth is v, velocity into time. Area gives the t into v, velocity into time. Velocity formula, you know, displacement by time. Then displacement is equal to velocity into time. Vt gives displacement, right? If you find out the area, what it is giving? It is giving the displacement. Vt graph shows the displacement. Look at here, we drawn the previous graph in the second case. Right, how you got that graph? Okay, that graph we got like this. What that graph indicates? Okay, this is the graph, velocity time graph. Time is taken on x-axis, and the velocity is taken on y-axis, right? This is for what it will indicate? This graph indicates uniform acceleration, right? Uniform acceleration. What is the meaning of uniform acceleration? Right? Acceleration is constant. Uniform acceleration. And acceleration is also positive. Acceleration is constant and positive. Okay? This is velocity time graph. In velocity time graph, acceleration is positive. Okay, in this case acceleration is positive. How we will tell that? We will take angle also. We know acceleration, this is x-axis we will take, and this angle is theta, right? And acceleration formula is tan theta. Here theta is above the x-axis, means theta is positive, right? Then acceleration is positive, right? Acceleration is positive. And this is for uniform acceleration. And now acceleration is positive means velocity increases with the time. Find velocity more than initial velocity. And let us see, the next one is, I am going to explain one more point, that is the graph. First rest completed, uniform velocity completed. Next, after the rest, uniform velocity, Uniform acceleration. Next, uniform retardation, right? A, B, C, D. Now, uniform retardation. Do you know what is retardation? If the velocity of object decreases with the time. Retardation means negative acceleration, right? Negative acceleration. Okay? Uniform retardation. How the graph will be there? Okay, let us see. And for this is uniform retardation. Uniform retardation means acceleration is negative. Velocity decreases with the time. Retardation means velocity decreases with the time. For example, driver applies the brakes. Okay, this is like this. This car is moving like this. Okay. And here, no need to take the example. Direct also we can tell. Velocity decrease means how you will get the graph. Right? Let us see here. This is time. And this is velocity. Okay? This is velocity. How you will get the graph? Starting, there is some velocity is there. Next, velocity decreases, right? Negative acceleration means velocity decreases. Velocity decreases here. Now, velocity decreases means you will get the like this graph. Velocity decreases, right? And if you want to know here, if you want to, after some time, look at here. Starting velocity, some value is there. It is going down. Means here its velocity is decreasing, means retardation. Here we know x-axis we will take it here. We will draw the parallel line for the x-axis. And this is the angle. Below the x-axis we are getting the angle. Okay, here the theta is negative we have to take. When theta is negative, then tan theta is negative. When tan theta is negative, then acceleration is negative and constant. Acceleration is negative and constant. Okay, and this is for uniform retardation. Okay, uniform retardation. And now we can draw these all. If you throw any object vertically upward, okay, how you will get the graph? If any object is thrown vertically upward, okay, and let us see E, one more graph I am going to draw, right? VT graph for an object thrown upward, thrown vertically upward. If you throw any object vertically upward, then how we will get the velocity time graph? Let us see. For this is the time, okay, and this is velocity. Remember that when you go, for example, if you are going upward, right, and velocity we will take as positive. Okay, positive y-axis. Velocity is positive and decreasing, right? Velocity, when an object moves upward, if an object moves upward, right, this is an object, it is moving upward. Then y-axis, positive y-axis, we will take as velocity positive, but it is velocity decreasing. Same object after going to certain point, highest point, it will return back. Okay, when it will return back, it is coming in opposite direction, negative y-axis. That's why we will take the velocity negative, but velocity increasing, right? Velocity increasing. While coming down, velocity increases, and while going up, velocity decreases, right? And this will happens when you throw any object upward. What happening first? Okay, velocity decreases it here first. Velocity decreases means goes down like this. Okay, after certain time the velocity become 0. After some time the velocity becomes 0. And next it will come back. Come back means it is a negative velocity, right? Here for example 5 meter per second. Don't take the velocities, some values. Okay, these are the negative values. And this is the positive and this is negative, right? And look at here, it is going down, means opposite direction. Velocity negative we have to take, opposite direction means velocity negative, and it is increasing, right? Velocity negative and increasing. Then we will continue the graph like this. We will get the straight line like this. We will get, this is the graph. Okay, what happening at here? This is totally traveling with the negative acceleration. Here in this case acceleration is negative. Okay, and it is uniform. Acceleration is negative and constant. Okay, acceleration is negative and constant in this case. Okay, up to some time its velocity decreases, and then after that its velocity increases. It is going down. Here when we will go this side, velocity increases. This is velocity on y-axis, velocity, right? This is positive y-axis, this is negative y-axis. While coming downward, negative y-axis will be there. Like this you will get the graph. Okay, if you find out the area we will get the displacement. If you find out the area, this has positive area plus a, and this has minus a, we will get area, because this is below x-axis. When you add the total area of this triangle plus this triangle, we will get in this case the displacement as 0, right? Why? Displacement is equal to area under the graph. Okay, area under the graph, what you are getting? Okay, area under the graph is plus a plus minus a. We are getting the 0 displacement. If you throw any object upward, it will goes like this and again return back. Okay, it will goes like this upward, and after going upward will return back. Right here we are throwing with some velocity u, and here final velocity is 0, and again return back. Initial point and final points are coincide. Initial point is this one, it will goes upward and again return back. Final point is also this one, initial point final point is coincide. That's why its displacement is 0. This is velocity time graph for an object thrown vertically upward. And now let us see one more point. By combining all the things, if you want to combine everything, then how you will get? Okay, take a screenshot and note it. This was very interesting topic. For the 9th class students, actually this is this totally I am combining the 9th and 11th class. That's why you are getting some extra information. Okay, and just for the 9th class students, you have to remember everything, right? How the graphs will be there. In the exam they will ask the shape of graph, shapes, VT graph, how you will get. Okay, and now let us see, we will combine everything, all the graphs. Some graphs we will combine and we will tell how the graph will be there, right? How the graphs will be there. This time is on x-axis, and the velocity is on y-axis. This side positive velocity will be there and negative velocity is also there. If object goes along positive x-axis, then positive velocity. If object goes along negative x-axis, negative velocity. Velocity is a vector, it has direction. Then in one way we will take positive, opposite to that we will take as negative. Right, now let us see how the graph we will get. Firstly, we got like this. This graph indicates what? This is the 1, and the 1 indicates what? Okay, 1 indicates uniform velocity, right? 1 indicates uniform velocity constant. Velocity constant means what is the acceleration? Acceleration is very simple. And let us see one more graph. We will get like this. This is the second graph. What this indicates? What this indicates? The second indicates that velocity is increasing, going up. Velocity increases means it has negative acceleration, right? Velocity is increasing means, but uniformly increasing, straight line it is there. That's why it is. It is uniform acceleration. Uniform acceleration. Uniform acceleration. Here acceleration is positive and velocity increases at uniform rate. At uniform rate, right? Okay, very good. You are getting everything. And the next, one more graph I will draw. If you will get the graph like this, what happens? This is the graph I am getting, and this is the third graph. Third graph. Okay, and what is this third graph? Third graph indicates what? Third graph indicates uniform retardation. Why? This is positive, theta positive, right? Okay, here theta negative. That's why acceleration negative for the third graph. Now here let us see uniform, this one, uniform retardation means, uniform retardation means acceleration is negative and constant. Acceleration is negative and constant. Here velocity decreases at uniform rate. At uniform rate. Okay, and now these are the combining all the graphs. And the next I am going to give that non-uniform acceleration. If acceleration is also varies, then what happens? Okay, A, B, C, D, E, F. Non-uniform acceleration. Non-uniform acceleration, right? Acceleration is variable here. Acceleration is changing. Acceleration changes. Then how we will get the graph? If acceleration changes, the graph will get like this. Okay. Here, like this, there, like this, there. This is time and velocity. Okay, it has different accelerations. It is not up to here some acceleration will be there, up to here some acceleration will be there, up to here some acceleration will be there, right? There are different accelerations are there. Non-uniform acceleration changes it here. Okay, and the next one example I will tell for you, that is there is some graphs, two graphs are there. Okay, one graph is there. Okay, there is a graph. The graph is like this there. This is time and this is velocity. Right, this is for A and this is for B. There are two bodies are moving. For the two bodies, for A and B are the two bodies. A and B, two bodies. VT graphs shown in figure. Shown in figure. Which body has more acceleration? That is our question. Which body has more acceleration? Which body has more acceleration? This is the first question. And the second question is that At what time velocities of two bodies are equal? Velocities of two bodies are equal. This is our question. Okay, let us see how to solve it. Very simple. Okay, which body has more acceleration? This is first we can write this angle is theta, and this angle we will take angle made by the x-axis we require, right? This is x-axis. This we will take as theta A angle. No, this is theta A. No. This is for the B graph. This is the theta B, right? And next, this is theta A. Can you tell from the figure which angle is more and which angle is less? This is this much, and this is this much. From figure we write solution for this. Solution. From figure we write one thing, that is theta B greater than theta A. When theta is B is greater than, we know acceleration formula is tan theta, right? B theta is more, means acceleration of B is more than the acceleration of B. Okay, when theta is more, then automatically acceleration is also more. If theta more, then A is also more. And the next, this is the first question completed. Okay, acceleration of B is more than, which body has more acceleration? B body has more acceleration. B body has more acceleration. Okay, and the next, let us see one more point in this. They are asking. This is the first one. The second point they are asking, at what time the velocities of two bodies are equal? Look at here. This is the intersecting point, right? This is the intersecting point. At this time, for the first graph velocity is this one, some v. For the second graph also at this time velocity is v, right? After time t they have same velocity. After time small t seconds, after time small t seconds, two bodies have same velocities. Right? Okay, this is our question. And now take the screenshot and note it. And don't worry about the 9th class students if you not understood, and because actually we are mixing with the 11th class, and if you have any doubt you can also comment in the comment box. Again I will explain these topics. And now this is combined with the 11th class, that's why you are getting some more information. Thank you for watching my lectures, and utilize the vacation time and utilize the lockdown period, right? हिंदी में बोलते हैं घर में बैठ के कुछ सीखो, right? आप भी कुछ सीखने के लिए ट्राई करिए घर में बैठ के and this is the happy learning, and I am wishing you all learn properly the subject and watch complete videos and share my videos lectures to other friends, okay, those who are nearby to you and those who are studying the near to your schools, okay, and compulsory subscribe my channel, watch complete lecture, and whatever the doubts you have, and you can write on a paper and you can send me, you can take a photograph and send to my WhatsApp number, that is 9963817138. Okay, thank you for watching my lectures.